So, ladies and gentlemen, dear guests, behold the presence of an icon in the world of artificial intelligence, an expert with nearly 30 years of technical and thought leadership experience, who has worked for a long time in global consulting companies and leading internet technology companies as a technical leader and product director. Please welcome Mr. Eric Bai, Principal Consultant of AI Solution at Huawei Cloud, talking about Huawei Cloud, reshaping industries with AI.
Okay, good afternoon, everyone. So my name is Eric from Huawei AI Department, China. So it's a great pleasure for me. Okay, it's a great pleasure for me to present here. And so my topic today is reshaping industries with AI. So it's reshaping industry with AI. So as we all know that while using AI technology into industries as well as into the enterprises, it's totally different if we use AI to individuals. So my topic session will describe some difference and how Huawei can meet the requirement to reshaping industries with AI, to popularize AI technology into industries. Okay, so AI is a GPT. Okay, well, the GPT I mentioned here means the general purpose technology, but not the generative pre-trained transformer architecture. So it's the same word, but it's totally different meaning of the GPT. So that the GPT is a collection of technologies that can span multiple use cases from the entire economic and produce the tangible value for the common society, the human lives. So in the past, along the history of the human life, so we ever had 26 GPTs up to now. So like in the stage of the electricity, in the stage of the internet, so we ever have many GPTs before. Just like the computer is also a kind of the GPT. So while AI is the latest one of the GPT, so we all know that. Well, AI is not purposed to replace people. It's not purposed to take money from people, to take jobs from people. The AI technology aims to help people, to benefit people with better life in the future. So, more interesting that if we see in the future, what's the next GPT candidate? So we may have many candidates in our mind. Maybe just like the nuclear fusion, infinite power. So maybe it's next GPT technology. And maybe another is the general intelligent robots. It's also another, maybe another GPT candidates in the future. But no matter the next GPT candidates are, AI is always will acting as the brain of the GPT technology in the future. In the future, maybe decades of years. So that means AI technology is the future. It will never out of date technology from our current perspective. So AI is a GPT, but AI cannot work alone. It must work with other industry technologies or enterprise production systems to produce tangible commercial value. That means AI, if we want AI to generate money, we need to combine AI technology with the industry core production systems. AI cannot work alone. So if we just play AI as a tool or as just a chatting tool, so the value is limited for AI. So if we use AI into the industry, then there will be a catalyst for AI to explosive growth their value to the people. So we estimate that in China, the AI adoption rate in the industry core production systems will reach to over 30% in next 2 years. So the number here may seem a little bit lower than your expectations, but I want to emphasize that the number here is only refers to the adoption rate of the core production systems, but not include any supporting systems like the OA systems, like the email systems, like the payment, maybe finance systems. It's not the core production systems. The core production system is the key. It's the core value chain of the industry enterprise. So if we use the AI technology into the core production systems, that means AI will act as the core control, one of the core control to improve the core business strength. So we can see that in China, so AI has entered into nearly all the industries, production systems today, and has started to generate more and more value. Okay, on the other hand, so if we ask a question, so can AI do anything? Is AI a Superman? So no, the answer of course is no. So there are maybe 3 use cases. So the first is that can AI tie shoelaces? Yes, the answer is yes, but it's unnecessary. So we all know that from purely technical capability perspective, some intelligent manipulator is very flexible, is very strong. They can easily to tie shoelaces for us. Of course, from technical, they can do that. But why we cannot see any kinds of AI machine to tie shoelaces machine in the market? Because tie shoelaces cannot afford the cost of AI. So that means the AI is costly, and some use cases cannot afford them. And for the second example, that in some industries, just like the transportation industry, the railway transportation use cases, so some defect is very rare. It's very rare. We can only experience maybe very few defect scenarios among the past decades of years. So can AI models be trained by very limited, maybe only 10, maybe 20 defect data samples? Can we do the training of the AI model based on so small data samples? Yes, the answer is yes. So, but it's very challenging. So we need to do many the data duplication by manual. We may need to generate the sample data and to do a lot of labeling of the data by human, so by human hands. So yes, but it's very challenging because the traditional AI technology always requires a large number of sample data. So, and the last use case is that can AI models be used universally in some different but very similar scenarios? Just like the case here is the electricity transportation line inspections. So there are many different but very similar defections. Just like, for example, maybe a bigger bird just shit on the electricity transmission line. So the line it cannot work anymore. And maybe another defection is not the bird, it's another animals maybe disrupt the transmission line. So the defection is different from the picture, is different, but it's very similar. And this kind of scenarios is over hundreds of the defection type. So can AI do that? Yes, we can do that. We can do it one and one and one. So until we finish all the hundreds of defection types. But it's very time consuming, it's very talent consuming. We cannot hire enough doctors, the modelers, to do so many different AI similar scenarios. So that means, based on that, we know that if we use the large model technology, we can address this kind of challenges which are faced by the traditional AI small model technologies. So overall, the large model technology applied to the industry. So if we already have a pre-trained large model foundation there, so we may require a smaller sample, lower talent requirement, and a shorter development cycle and a lower cost to apply the large model technology into the industry scenarios. For example, we can see the picture here, that the number here, so the number in the left is that the traditional manually the small model development method. So we can see the number in the right, the sample data number, the cycle, the talent requirements. We can see the number here. Well, on the right, if we use a pre-trained model as a base, so we can see the number in the right. It's in average is 5 to 10 times decrease to the data, to the talent, to the cycle, etc. So, and more important that the traditional small AI model cannot inherit knowledge of the industry. So that means ever before the traditional AI development can just duplicate different cases, and cannot learn the new knowledge and accumulate the knowledge into the large model base. It's a very key pain point for the enterprise, because the enterprise is a long-term company, a long-term business. They require to accumulate the industry experience, industry knowledge into some place. Well, large model is a very good candidate to accumulate this kind of enterprise knowledge. So up to now, we know that AI and the large model technology are inevitable choice in the future. So we can all agree with that, because the large model technology is more generalized, and they require smaller size of data, and require smaller talent requirement and shorter development cycle. And the second point is that it's not easy to apply large model technology into enterprise. We all know that ChatGPT, so it's a personal tool. It's a very strong personal tool. But ChatGPT is serve mainly to the personal. We can chat with ChatGPT freely. So, but it's a personal business model. Well, apply the AI technology into the enterprise. We need to follow different steps. For example, the first step is that we need to get a pre-trained large model first. We call it the foundation. So if we look at foundation, it's more like an outstanding graduate from the technical university. It's a fresh new worker. It's a very smart. It's a new worker just stepped out the school. So it's the foundation, the pre-trained foundation large model. Well, if we employ the graduates to serve some specific industry scenarios, so we need to train or fine-tuning the graduates to be familiar with some industry. So that means we need to retrain or re-educate them to know industry, the background of industry, the regulation of the industry, the working environment of the industry, the machine, the equipment of the industry. So that's the second step. Well, the last step is that if we want the worker to serve or to resolve the specific scenario problems in the industry, so we need to retrain them again with the specific scenario environment. How, follow what kind of a process, and use what kind of tools to make what kind of decisions to resolve the scenario-specific problems. That's the requirement of the industry to AI. So it's largely different compared to personal usage, personal aimed ChatGPT kind of large model technologies. So next, I would introduce some typical large model use cases in industries in different countries all around the world. The first is that we call it the city governance, or somehow it's all called the smart city. So the core of the solution are large multi-modal models. So we can see in the center over here. So the large multimodal models collecting all the data from the hundreds of sensors all around the city. So maybe voice, maybe video, maybe image, maybe text. So, and they will have task scheduling, and using the large model technology, it can generate decisions, and they can dispatch attack the Dubai now. So we can see that after the storm, a big tree is fallen. A big tree is fallen, and the camera can check. Okay, the train is fallen, and the back beside the train is also fallen, and a garbage box is also pulled out. So we can see the different, the red color, the green color, and the people, the citizen in the city can chat with the robots and to chat. Okay, what's the problem of the street? And then the large model systems can generate different tasks. It's a fallen bicycles, it exposed garbage, it's a fallen tree, it's a standing water. So 4 tasks will generate it in minutes and dispatch the tasks into different departments, the city governance department. And another use case is that the mining industry. So we can see the real case, all the case I show here is the real case. So the mining industry, we can see that the inspectors here can check with a 98% accurate rate for the foreign objects identification during the transmission line of the mining. And on the right hand, that 95 accuracy rate of the safety violation inspections, detections of the workers, and to improve the safety level of the different workers. So they can automatically check and warning the worker if we correctly wear the safety box, for example. And this kind of large model technology will be replicated to over 4,300 mines in China in the next few years, covering the end-to-end mining industry value chain, the drivage, the equipment control, the transport, the ventilation, the cleaning, and of course, safety violations of workers. Okay, this is another example of the power grid. Well, so power grid, the state grid, so China have a #1 biggest enterprise we call the state grid. Okay, state grid is also the #3 biggest in the global Fortune 500. So it's a very big it's a very big company. So the state grid is in charge of the construction, operation of nearly all the electricity power of China. So in the last year, so the total volume of electricity power operated by the state grid, one company is 2 times of a total electricity volume of America. It's 2 times of America. So it's a very big enterprise. And so state grid is very experienced AI practitioner in the past few years. And they already built over 1,000 AI models or AI-related modules to use into their core production systems in the past few years. But they still facing very big challenge while adopting the AI technology. So the #1 challenges they are facing is the data sampling. So we can see in the right hand the challenges that, well, the y-axis is the volume of the samples data. Well, we can see some use cases, AI use cases have many sample data, so it's very high. Well, many scenarios has only very limited sample data, so we call it the long tail scenarios. And so State Grid decided to roll out a strong large model technology, and they can effectively address the limited sample data AI use cases. And after the large model adoption, so we can see they have many business benefits achieved. So many number are increased. And the next use case is that the railway, the TFDS, it's for automatic fault detection. So the large model, CV large model, after a few months, very quick, it's a few months fine-tuning based on a pre-trained large model. The large model can identify over 400 fault types from 67 freight car models in seconds. And in this client, so they have totally 260 electronic inspectors installed. And these inspectors will generate 4 million of photos every day, 4 million photos. And 95%, that means 3.8 million photos, can be safely screened out. That means labeled as the safe, non-problems, by the large model in seconds. So so it decreases a huge amount of a human inspector's workload. And more important that the screen out of 3.8 million photos is 0 mistake. So that means the misdetection rate is 0. The last use case is that for the drug, for the healthcare. So the large model, molecular model can accelerate the drug discovery. So it's a very interesting area for large model use cases. So in general, that means the large model can learn, can be trained by the more than billions of the chemical characteristics of billions compounds trained into the large model, And then the large model can help to predict many things to accelerate the new drug discovery R&D process. So we all know that to develop and go to market a new drug is very long, maybe 80 years, maybe 10 years, and the investment for the new drug, for one new drug, is billions of dollars, US dollars, is very huge. So, using the large model technology into the drug discovery tree can dramatically decrease the cycle and the investment volume of the drug industry. So the use cases in the right is that is one of the tier 1 drug research lab in China. So Huawei cooperate with the lab using the Huawei's the molecular large model technology. And we can see that in the lead compounds development cycle, so usually they will spend more than 1 year to confirm or to identify the lead compounds, the scope. But after using the large model technology, so they shorten the cycle into 1 month, into just 1 month. Only in this R&D cycle, they saved more than 70% of the R&D cost. So it's a dramatically decrease to the drug R&D industry. So we just, as I just mentioned, that apply the AI large model technology into the enterprise is difficult, and is different compared to use the AI in personal, like ChatGPT. So Huawei, we defined 3 tiers of the architecture to use AI technology into the industry. So we call it the L0, L1, and L2. So we just know that it's not the latest version of the. So just I mentioned that the L0 is just like graduates just stepped out of school. Well, L1 is retrained by industry general language, while L2 is just like a specific industry with specific scenario knowledge expert to resolve the problem of the scenarios. So we need to establish the large model technology step by step. So, it's not to say that we must establish a 3-tier of AI capabilities to use AI into the industry. It's not required. And some of the customers can use just the L1 and L2 directly from the cloud. Okay, they do not need to establish their own foundation large model. And some of the customer just want to establish their L0 foundation model and then jump into the L2 because their business environment is not so complex to afford the L1 large model tier. So that's all can be work. But in general, from the overall perspective of all the industries, so we recommend that we need to treat the 1 to 3 different layers as a necessary framework of AI to generate tangible value for the industries. And to support the industrialization of the AI large model technology, so Huawei also have the large model engineering suite to accelerate the process. So the suite is the first is data engineering. Now data engineering, the key point here is that we can do the auto data cleansing. Okay, so as we know, so if we train or fine-tuning LLM large model, so the data quality is very important, and the data quality will decide the accuracy rate for the trained out for the large language model finally. So the data cleaning is very time consuming and labor consuming. So with the tool, we can do the auto data cleansing. We can check any duplications, for example, of the text training data. And from the data engineering, we can also do the semi-auto data labeling. Okay, so for example, that we can provide an online auxiliary prompt writing functions for SFT, and the multi-person online ranking labeling tasks. And for the middle development suite, so we offer 3 workflows: the self-supervised training, SFT, and the reinforcement learning. So these workflows already embedded into the tool and can facilitate any large model development project. And finally, is the application development kit. That means that is a set of tools to help establish the applications, okay, to use the large model AI capabilities. Okay, up to now, so Huawei has ever completed more than 2,000 AI projects in the recent years, so nearly all around all the industries, all around the world with all industries. And the final slide is that Huawei will launch a new cloud site in Egypt in next month. So that's it's the first site in Egypt. And the public cloud in Egypt will follow all the laws, all the regulations of the Egypt, and all the data will stored in the Egypt. So, and welcome everyone for the summit in the May, in the 21 of the May. And after the launch of the new Huawei Cloud Egypt site, so Egypt will be one of the central site with 50 milliseconds of the network latency. So compared to all around the world, so we can see that the Egypt, Saudi, and UAE is over the average network latency compared to Europe, compared to South Africa, and so it's a very quick network. So that's my last slides. And if you have any questions or interesting point, let me know. We can discuss.
So,
Yes, I'm also from Huawei, so just want to add a supplement to the question because Mr. Eric is coming from our headquarters in China. He just landed this morning. So I'm a local employee, so I'm based in Egypt. I know the more details about the Cairo region. So actually, we will have 3 available zones for our Cairo Cloud. And the first AZ will be in the Telecom Egypt data center in Smart Village. So it's in Cairo. And all the data will be stored in Cairo as well. So it's purely, the Egypt cloud. So everything is controlled and managed by the Egypt regulations and the laws. So you can have a rest assured to use the cloud as just a local cloud. Thank you.
So my question is, which tier is the data center you're building in the Cairo? Which level? To which tier level is the data center you're building? Tier 1, 2, 3, or 4?
Maybe I have my colleague to answer.
Yes, so for our data center, we have the standard, so at least tier 3. So now the current data center we use in Telecom Egypt is tier 3. Yes.
thank you so much, Mr. Eric. We were
Okay.
really delighted to have you today. Thank you so much.
Thank you.